Hey everyone, welcome back. In this video, we are going to be talking about influential points. So first, let me just define that real quick. So an influential point, it is any point, and of course, this is all tying to regression, simple linear regression. So an influential point is any point that greatly changes or has like a substantial effect on any point that greatly changes the slope, y-intercept. I'm just going to write it out as S. That's the standard deviation of the residuals. So again, any point that greatly changes the slope, y-intercept, standard deviation of the residuals, the correlation coefficient, and the coefficient of determination. Now, these influential points kind of fall into two different categories. One is an outlier. So an outlier with one variable data was just anything that looked like it didn't really belong. An outlier in two variable data is a point far above or below the rest of the data. Okay, so the other influential point certainly can be an outlier as well, but it's known as a point that has high leverage. High leverage. Okay, so an influential point that has high leverage is far left or right of the rest of the data. So actually, let's just go ahead and look at these on an online application here. So I'll get to that page right now. All right, so I've got some points already plotted on this. Looks like we have 12 points altogether with a correlation coefficient of 0.5593. On this, we also have the least squares regression line and also the mean of the x and y values plotted as lines. So the average value is right here where they intersect. The point of averages, remember the least squares regression line always goes through the point of averages, the mean for x and the mean for y. So just to give you a visual of what I just talked about, an influential point in terms of being an outlier is far above or below the rest of the data. So if I put a point way up here, let's see what happens to the correlation coefficients. And you can see it went all the way down to 0.2130. Massive change there. Again, that's an outlier because it's far above the rest of the data. A couple other things. We know that the correlation changed greatly, which means the coefficient of determination is probably going to change quite vastly as well, because remember, it's just the square of this value. The slope and y-intercept are also things you want to take a look at, and they didn't really change that much. So slope is the steepness of this line, and we'll say the y-intercept is wherever our regression line is intersecting kind of this line right here. So pay attention to the steepness of this line and where it's crossing the y-axis over here. So you see, it doesn't really change it much. It drags the entire line up, but didn't really have that big of an influence on the slope. The steepness of this line is staying fairly constant. The y-intercept changes just a little bit, and again, the correlation coefficient goes down a lot. Okay, so an influential point is something far left or right of the rest of the data points. So if I put a point way out here, let's see what happens to the correlation and keep an eye on the slope and y-intercept. Okay, so this high leverage point did a lot of stuff. It dragged the correlation coefficient way down, and you can see that our line is very flat now. It's not nearly as steep. And also, the y-intercepts increased. I'll take away this point so you can see. So our y-intercept was down here, and now it is very close to this average x value. or average y value, my bad. Fantastic. That's just about it. Those high leverage points, if I would have just stuck it like way over here, you can see it's not really influential. It helps our correlation coefficient, but it does not really have a big change on the slope or the y-intercept. There's 5 things to really keep in mind for influential points. I'll write them here just to reiterate that point. We need to keep an eye on the slope, which is B, the y-intercept, which the variable is A, the correlation coefficient, the coefficient of determination, and the standard deviation of the residuals. So that's one more thing I want to take a look at real quick on this graph. Let's put a little bit more points in here. Now, if I had a point way up here, and I can show the residuals actually, the standard deviation of the residuals, if I take this point away, is the standard deviation of the residuals going to increase or decrease? Kind of think about that for a second. If I take this point away, what's going to happen to the standard deviation of the residuals? And hopefully you're able to come up with, if I take this away, the average error between our predictions, which is on the blue line, to the actual values, which are the red dots, it's going to decrease. If I take this away, the average error of our predictions is going to decrease. So that's the gist of influential points. Let's go through a couple exercises in Khan Academy. I'll clear the stuff over here. So here's a pretty standard question. Awesome. Consider removing the point -10, 235, and calculating a new least squares regression line. What effects would removing this point have? So the standard deviation of the residuals would decrease. And hey, so that is definitely going to be true. This point is further away than the average distance of these points. So this residual is greater than average. So if I took it away, absolutely the standard deviation of the residuals is going to decrease. Let's look at the other stuff here. The slope of the least squares regression line will get less steep. Maybe I can try to sketch a new line to make it pretty clear. So the slope, a good way to think of it is we have an average somewhere, maybe it's like right here. And this is like a string that's pulling the line in its direction, and it kind of swivels on this fulcrum point right here. Swivels on this point. So if I were to remove this point, no longer there, this line is going to drop. It's going to flatten. And maybe the new regression line looks like this. So definitely, it is not as steep as it used to be. It will definitely get less steep. Let me get this stuff out of the way. This last option, the y-intercept of the least squares regression line would decrease. I just erased that line, but you could probably see that I drew my new line and it looks more like this. Looks like we would have crossed maybe somewhere around, I don't know, 80 instead of like 125. So indeed, the y-intercept did decrease. Fantastic. Let's go to try another one. Okay, so this one is only an outlier. This one does not have high leverage. What effects would removing the point 38, 380 have? It says the correlation coefficient would get closer to 1. That is absolutely true. This point that is far away from the regression line is decreasing the correlation coefficient. So yes, the correlation coefficient would get much more strong. Our relationship would be much more strong. The standard deviation of the residuals would decrease. So this one, by removing it, we are not going to have as much error. So that would also be true. This last one, the y-intercept would decrease. So this point, again, it's kind of like a string. It drags the line in its direction. So I think if we got rid of this point, the line would drop a little bit. So that would mean the y-intercept would most likely decrease. That looks good. Let's check. Awesome. I'll do another one. Scattered plot below displays a set of data along with this regression line. Okay, consider removing the point 7586. So this point is directly on the regression equation, or just about directly on it. What effects would removing this point have? The coefficient of determination would decrease. So really think about this one. Since it's so close to the least squares regression line, it's really helping our correlation coefficient. So if we got rid of this, our correlation coefficient is going to go closer to 0, which means this value is also going to decrease. Again, by removing that point, our relationship is going to be not as strong. So it's going to get closer to 0, not 1. And then for the standard deviation of residuals, I mean, this residual is like essentially 0. So if I got rid of it, my average prediction error is going to increase. It's not going to decrease. So I could check, make sure I got it right. I did not. What in the correlation coefficient would get closer to 1. It's going to get closer to 0. I think I said that, but I clicked that. Correlation coefficient is going to get closer to 0. Yeah, my mistake. By removing that point, our relationship is not as strong. The correlation coefficient is getting closer to 0. I don't know why I did that. Okay, well anyways, thanks for watching, guys. I'll get some practice problems for you, and I'll see you in class. Okay, bye.